Every year, in the world and in our country, the number of individuals suffering from cold chain breakdown, food poisoning, and even more serious health problems is increasing. And due to the cold chain breakdown, significant amount of food and health products are wasted.
Cold chain is a temperature protection system which should be kept at certain temperatures, and it is necessary for the products to be kept in storage, transportation and storage until the consumption of foods and health supplies that are broken down when they go beyond these temperature values.
In this project, we aim to minimize the number of food poisoning cases that may be caused by cold chain breakdowns, the number of individuals suffering from more serious health problems, and the amount of food wasted too much. In addition, we aim to make a useful detector that consumers can understand whether the product's cold chain is broken or not when buying frozen and fresh foods. The aim of this project is to find practical, cost-effective, and easily accessible physical solutions.
Frozen foods are stored at -18 Celsius, and when they reach the temperatures above 2 Celsius, the microbes begin to grow. Thanks to the method we developed, we can easily understand that these foods exceed 2 Celsius. The basic working principle of this method is based on the evaporation of liquids. We have chosen diethyl ether as the most suitable liquid for our purpose. In order to increase the usefulness of this method, it is convenient to place them in air-permeable fabrics at one side of the package. In this way, both the ether will not spill and evaporate easily. One thing to be mentioned here is that evaporation is at any temperature. This means that evaporation at -18 degrees will occur, and the ether in the package of food that has not reached 2 degrees may evaporate and mislead us. In order to be protected from this situation, the amount of the ether to be put into the vesicles should be adjusted according to the expiry date of the product.
Fresh foods are foods stored around +4 degrees. When they are removed from their cabinet, they do not experience a great temperature and temperature change as much as frozen foods. We also worked on ethyl alcohol thermometers to determine whether the cold chain of these foods are spoiled, and we put the same amount of colored alcohol in the capillary tube used in a thermometer that can measure ±4 degrees. We cut the thermometer and put it there. We also glued the sealed part of the tube with Japanese glue so that it would not breathe air and emptied the air inside it. When we put the thermometer in +4 degree environment, we saw that the colored alcohol in it was painting the paper we put it in, and the paint still remained even when the temperature fell again.
Basically, the system can be characterized as a multi-point measurement. While prototyping, we have placed 3 load cells in 3 different points under the oval balsa plate we cut in CNC. We have connected all the load cells to an Arduino Uno microprocessor with jumper cables. We also included an LCD in the system to see the weight data update. Our diagrams were written using the Arduino IDE. In this way, the markers will be able to detect the weight change on the shelves of the product shelves placed on the shelves so that they can easily monitor the products on the shelves.